Hi guys, welcome to Colossus mathematics class. So today we'll be talking about linear transformation. So if you're talking about linear transformation, the definition of a linear transformation is let U and V be a vector space over a field F with mapping from of T, mapping from U to V is called a linear transformation if it satisfies these two properties. So if it satisfies this following property, the first property is additive closure, which is if I have T of U1 plus U2, it should give me T of U1 plus T of U2 for every x in U. Are you getting? For every U1, U2 in U rather, not X. So for every U1, so let's do it this way. For every U1, U2 in U. So this is the first property it has to satisfy. And the second one is that it has to satisfy this, that T of alpha U should be equals to alpha T of U. For every U in U and alpha in F. Don't forget your alpha is a constant in a field. So if you want to get this, I talk about it in the video vector space. So you can check that out and check all the 10 axioms under vector space. So these are two axioms under this vector space. So let's see few examples on this. So let's say I have a question. Let's say I have a question. I have given that T of x1, x2, and x3. I have it to be 2x1 minus x2 minus 5x3. So let's say I have something like this. If I have something like this, then I have the other one to be minus, so let's just check one, minus 4x1 plus 2x2 and minus 10x3. So let's see this example under vector space. So we are seeing this example. So solution. So the solution is that it has to satisfy the first and second axioms. So now this is our U1. So you have to note first that this is your U1. So you have to create U2. So create U2. I get what I'm saying. So if you are creating U2, let our U2 be, so this is our T of U1 and our T of U2. We have x1, x2, x3. So let our T of U2 be y1, y2, and y3. Are you getting that now? Don't forget that your T of U1 is what? x1, x2, and x3, right? So after that, the first axioms you want to check is this first one. That is T of what? U1 plus what? U2. So your T of U1 plus U2 will be what? What's your T of U1? x1, x2, x3, abi, plus y1, y2, and y3, abi. Are you getting what I'm saying now? So your T1 and this will be x1 plus y1, x1 plus y1, then the next one x2 plus what? Y2, and x3 plus what? Y3, abi. So this is what I am going to have. Now, what we are going to do next is that from this your question, anywhere you see x1, you will put this value. Anywhere you see x2, you put this. And anywhere you see x3, you put this. Are you get what I'm saying? So the equation we have here is what? 2x1 minus x2 minus 5x3 and minus 4x1 plus 2x2 minus 10x3. So this is the equation I have. So how will you do that? Anywhere you see x1, put this. So this is your x1, this is your x2, and this is your x3. So that will now be what? 2 open bracket x1 plus y1 minus what is the x2? x2 plus y2 minus 5 open bracket what is the x3? x3 plus y3, right? I'm sure you are following. Minus 4 open bracket what's your x1? x1 plus y1 minus plus 2 what's the x2? x2 plus y2 minus 10 x3 plus y3. I'm sure we understood that, right? So open this bracket, that will be what? 2x1 plus 2y1 minus x2 minus y2 minus 5x3 minus 5y3, right? So let's go to the second one. That will be what? Minus 4x1 minus 4y1 then plus 2x2 plus 2y2 minus 10x3 minus 10y3. So this is what you are going to have, right? Don't forget we are solving for t of what? u1 plus u2, abi? So that means my t of u1 plus u2 will not be. Now the next step you have to do here now is you have to collect like terms. So you have to collect like terms. So this one now be what? 2x1 minus x2 minus 5x3. That is only the x will stay at one side and the y will also stay at the other side. So your plus your y will be what? That will be 2y1 this, then minus 2y, minus y2, then minus what? 5y3, right? So I'm going to have something like this. So let's do for the second part. So this one was minus 4x1 minus what? Plus 2 plus 2x2 and then minus what? 10x3. So the other part was minus 4y1 plus 2y2 minus what? 10y3. So this will be your equation. So from here you can see that your t of u1 plus u2 is the same thing. If you look at this now, you see that this is the same question you are given, which is your t of u1. And if you look at this is the same thing as our t of what? u2 that you created. You know we created u to be what? To be y from here, and you see that the same values they have is the same values this one have also. So if that is the case, we are going to go to the second axioms. We are going into the second axioms now. So the second axiom, so let's do for the second axiom now, the second property, which is that of scalar multiplication. So this one states that your t of alpha u should be the same as what? Alpha t of u. So how will you do that? You know that your t is what? Your t is x1 x2 x3, abi? That means your t of alpha u will now be what? Alpha x1, alpha x2 and alpha x3. So like the same way we did for the addition, anywhere you see x1 in this place now, you put this. Anywhere you see x2, you put this, and anywhere you see x3, you put this. So this is your new x1, x2 and x3. So you can go ahead and pause the video while you check that. So that will now be, so your t of alpha you will now be, what's your question? You have 2x1 minus x2 minus 5x3 and minus 4x1 plus 2x2 minus 10x3. So anywhere you see x1, you put alpha x1. So that will 2 alpha x1 minus alpha x2 minus 5 alpha x3, right? And this one got minus 4 alpha x1 plus 2 alpha x2 minus 10 alpha x3. Now, if you look at this, you can see that something is common in between them. You see that something is common in between them, which is what? Alpha. So bring alpha out. You will be left with what? 2x1 minus what? x2 minus 5x3 minus 4x1 plus 2x2 minus 10x3. Did you get that now? So you can see that your t of alpha u is the same thing as alpha. If you look at this, you see that it is the same thing as the question you have, which is your t of u. So with this, you have been able to prove for your first axiom and your second axiom. So with this, I'm sure you've been able to learn something in today's class. So don't forget to subscribe, like, and share. Thank you very much. Once again, I'm Colossus L. Socrates. Thank you.